Along the shore the cloud waves break, the twin suns sink behind the lake, the shadows lengthen in Carcosa. That was the first stanza of Casilda's song, the poem that opens Robert W. Chambers' 1895 masterpiece, The King in Yellow. It is a series of short stories centered around the titular cursed play and the madness it instills in all who read it. I used to think that this premise was somewhat fantastical. After all, how could a work of literature cause such harm to so many people? Unfortunately, it is a phenomenon I now understand all too well. Hi, I'm Theta Minor, and I'm here to talk to you all about Pigeon Milk. Before we begin, I'm just going to do a quick overview of our schedule for today. I'm going to introduce to you the species in question, explain the composition and formation of this substance, go over the adaptive benefit of this trait, speculate about its evolution, and then give a quick summary at the end. So to begin, today is all about the rock pigeon, or Columba livia. It is also sometimes referred to as the domestic pigeon, or feral pigeon, due to them all being the same species. There is some evidence that we domesticated them close to 10,000 years ago, so they've been living with us for a while now. I feel as though they are unfairly maligned by the general public, especially with the rats with wings moniker, but if I got started on that tirade, I'd be here all day. Let it be said, though, that if I see any of you write rats with wings in the comments section, I'm going to be very upset. They are primarily granivorous, meaning that they eat seeds and grains. They engage in very extensive parental care, but the full scope of that is a story for another time. And as mentioned before, I just think they're really nice and interesting birds. I probably didn't need to include this photo. Even if you've never set foot in a city in your entire life, you've still probably seen a pigeon before. But if you're anything like me, you just like looking at them. Anyways, what was that about pigeon milk? As I'm sure you know, most birds tend to feed their young regurgitated, pre-digested food. This is kind of gross. That's basically just vomit, right? And the main issue with it is that the nutrients the chick is getting are now super dependent on the quality of food that the parent can find. Chicks typically need food rich in proteins and fats to sustain their rapid early life growth and development, and grains and seeds don't typically have the optimal nutritional profile for that, being more rich in starches and sugars. To deal with that, pigeons can produce a milk-like substance in their crop-gland that they feed to their young. Penguins can also produce it, but probably for different reasons, and only the males can do it. With pigeons, both parents can make bird milk. Now I know what you must be thinking, is this actually milk? And to the relief of some of you and disappointment of others, not really, no. This is an example of convergent evolution, which is when two different organisms independently evolve the same solution to a problem. Pigeon milk is a protein and lipid-rich substance made via the desquamation of the crop gland. Now, desquamation is a word I was not familiar with prior to researching for this presentation, but it basically just means the shedding of a thin layer of cells. So to make this substance, pigeons are shedding a layer of cells from their crop gland, mixing it into a liquid, and feeding it to their young. And the texture is more comparable to cottage cheese than milk. So I may have been a little quick on the draw with calling other birds gross, because this also seems like a deeply unpleasant process. Alright, enough about the how, let's get to the why. When measured by dry weight, pigeon milk is approximately 55% protein. That provides an ideal density of nutrients to support early life growth in a chick. Because of this, squabs grow very quickly, going from hatching to being basically indistinguishable from an adult pigeon in about 28 days. If you've ever heard anybody jokingly say that they've never seen a baby pigeon before, this is why. They grow up exceptionally quickly. It also ensures that the squab will survive even when raised by parents subjected to nutrient-poor diets. Under similar conditions, other birds, such as chickens, will simply fail to raise their young to adulthood. Needless to say, most pigeons in the modern day are subsisting on nutrient-poor diets. They live in cities and primarily eat the scraps and crumbs from all of the grain-based foods that we humans make. These are even more nutrient-poor than the seeds they'd typically be eating, so being able to provide their young with something more nutritious is vital to the pigeon's survival in urban environments. I mentioned before that pigeons are not the only birds to produce milk. Penguins and flamingos can also desquamate their crop glands to feed their young. This is such a specific adaptation, it compels one to ask, do these traits share an evolutionary origin? No, they do not. Pigeons and penguins are as distantly related as any two taxa within Neo-Aves can be. For context, the Neo-Aves taxa contains all modern living birds, except for paleognaths, which are ostriches, emus, and their kin, and galanceres, which are ducks and geese. Flamingos' placement on the Tree of Life is less certain, but they're definitely not close relatives of either pigeons or penguins. We have to assume that this is another instance of convergent evolution, because the alternative is that crop milk production is an ancestral state in all neo-aves, and all but 3 taxa have independently evolved to lose that trait. That is not a parsimonious explanation. It couldn't hurt to check for evidence in the fossil record. That's what I told myself anyways. Oh, how wrong I was about that. The crop gland is soft tissue, which does not fossilize readily. That being said, it can still occasionally show up in the fossil record. I found a paper analyzing the fossils of 2 different distantly related Cretaceous bird species, which found evidence of a crop gland in both of them. While crop milk is not a shared trait among most birds, a crop gland is, and it appears to be a very old adaptation. There's no fossil evidence of crop milk, but how would that even happen? How would the milk fossilize? And this is where I should have stopped digging. This is where I should have stopped my research. I had my answers, but I had to keep pushing my luck. Continue watching this at your own peril. I don't remember making this slide. Okay. The last thing I'm going to be discussing today is the deeply, deeply troubling concept of dinosaur milk. This paper has ruined my mind. Its miasma haunts my every waking moment. It is all that I am now. I am but a conduit, a vessel meant to spread it to as many other people as I can before I burn out like the black stars of Carcosa. The evidence for this claim is as follows. Hadrosaurs subsisted on a diet that would have benefited from a crop-like structure for short-term food storage, mainly grasses. They are a taxa known to have engaged in fairly elaborate parental care relative to most other non-avian dinosaurs. Their offspring are believed to have grown rapidly, likely due in part to this parental care. Their offspring would have lacked teeth or the necessary microbiota to digest any regurgitated grass from their parents, at least early in life. These ecological factors potentially suggest that hadrosaurs both had a crop and produced crop milk for their offspring. Modern birds are dinosaurs, after all, so it would not be particularly outlandish to suggest that some dinosaurs may have had a crop. To provide some brief solace from this madness, no fossil evidence of a crop gland has ever been found on a hadrosaur specimen, and crop milk, naturally, cannot exist without a crop. That being said, I established earlier that crops do not fossilize well, so a lack of fossil evidence for a crop is to be expected. This is not a certainty, but the existence of crop milk in this taxa is definitely a possibility. In conclusion, crop milk is a major component of the rock pigeon's reproductive strategy, allowing them to rapidly rear healthy offspring. It is not the same as mammalian milk, both in chemical makeup and evolutionary history. There is a compelling ecological argument for the existence of crop milk in some non-avian dinosaurs, and my mind has been broken, and now so has yours. If you have any further questions about this topic, or any similar topics, feel free to ask me in the comments. I will be happy to bestow upon you all my master's degree worth of pigeon facts. Sources are listed in the description.